All right, guys, so I'm going to go through the Unit 2 practice test. This is a multiple choice test, and it's modeled to look pretty much like your unit test that you'll be taking. So there are some different strategies for answering multiple choice questions than just open response, and sometimes it can actually help you out if you get stuck on one. So I'm just going to work through these, and you can fast forward to any specific problems or questions you had, or you can watch through the whole thing just to get a good overview for the test. So I am just starting here, and I kind of split them up into sections. So here we're starting with slope. All right. I want to get my pen going here. All right. So this first question says, find the slope of the line through the point 3,7 and -1,4. So I'm given 2 points and I'm finding the slope. So if I'm given 2 points and finding a slope, I want to use the slope formula, which is m, and m is the symbol for slope, equals change in y over change in x, or you might know it as y2 minus y1 over x2 minus x1. So I can label my points, x1, y1, x2, y2, and then I'm just going to subtract. y2 minus y1, that would be 4 minus 7 on top. And on bottom, I have x2 minus x1, which is -1 minus 3. I simplify this. 4 minus 7 is -3. And on the bottom, I have -1 minus 3 is -4. Be careful here. A negative over a negative cancels, and I'm left with a positive 3 over 4. And you better bet one of those answer choices is going to be, well, actually it's not. A good distractor would have been -3/4, but it's not even an option. So the only one that matches is B, 3/4. All right, well, moving on. Number 2, find the slope of a line through these 2 points. We're going to do the exact same thing. So I've got x1, y1, x2, y2. Slope equals y2 minus y1, which is 2 minus 2, over 6 minus -3. Now 6 minus -3, this minus negative here becomes a plus. 2 minus 2 on top is 0, and 6 plus 3 is 9. 0 on top, or 0 divided by anything, equals 0. If the 0 were on bottom, it would be undefined, and you can plug that in your calculator to check if you don't believe me. But some of us are still getting confused by 0 and undefined. They are two different answers, and if it's 0 on top, it equals 0, and if it's 0 on bottom, it's undefined. So the correct answer is C. All right, number 3, which graph has a slope of -2 over 3? Now, if it's negative, I already know it's going to be going down, so I can get rid of any that are not going down, like A is not going down, B is not going down, so it has to be C or D. I'm looking for one that has a slope of -2 over 3, so it's going to go down 2 over 3. Now, I don't have a y-intercept, so I don't know its starting point, so I'm just going to have to find any 2 points and count the slope. So this one here has a point here, and it appears to have a point here, and we're going down 2 over 3, so that one looks good. This one has a point here and a point maybe here. See, it doesn't cross through this corner or this corner. So I'm going down 3 over 4. So that's not right. The answer has to be C. All right, number 4. It says, in 1996, there were 171 area codes in the United States. In 2007, there were 215. Find the rate of change from 1996 to 2007. Well, rate of change means slope. Slope is change in y over change in x. So what I have here are 2 data points. I could put it in a table, or I could just write the points out, but usually x represents time, and in this case I have years. The first year I have is 1996, and the second year I have, see, that's right here, 96. In 2007 is the second point. And then the other values I have are area. We're talking about area codes. So there are 171, and then there was 215. So it, excuse me, in 96 there was 171, and then in 07 there were 215. And these are area codes. So I just find change in Y over change in X. So I'm going to subtract these here. 215 minus 171 on top, divided by, I have 2007 minus 1996 on bottom. So let's see what we get here. 215 minus 171. That's 44. Divided by 2007 minus 1996. That should be 11 years. And 44 divided by 11, I know that that equals 4. And that's my answer. And it looks like it's right here. And so what that means is this is increasing. So it's increasing at a rate of 4 area codes per year. That's what we're actually finding here, is how many area codes is it increasing by each year. All right, so I'm going to move on to the next page, which is some more slope practice and a couple applications of slope. All right, so 5, which table of values represents a linear function? So if we're looking at a table of values and trying to decide if it's linear, we know it's linear if it has a constant rate of change. Okay, those words tell us that it's a linear equation. So we're looking for patterns in the changes in x, and here it says f of x, but that's just another way of saying y. Y is a function of x. So we're specifically looking for a pattern in which x is increasing at a constant rate, increasing or decreasing, and so is y. So we're going to take a look at these and see if we find a pattern. So this first one, 0 to 1, that's a plus 1. 1 to 2, that's a plus 1. 2 to 3, that's a plus 1. So it looks pretty constant here, but down below we have 5. What's the difference between 5 and 0.5? Well, 5 minus 0.5. This is a minus 4.5. And then from 0.5 to 0.05, this is minus 0.45. So this is not the same rate. Now, if you continue, you might see there is some sort of pattern going on here. It looks like the decimal is being moved one place further to the left, but this is not the actual rate. When we subtract and find the difference is not constant. So this will look like something, but not a line. Here we have the same constant change on top, 0, 1, 2, 3. Down here we're going from 1 to 0.25 to 0.0625 to 0.15625. That does not look like it's a consistent decrease, so I'm going to say no there. Same thing on top here, looks good, but here we've got 0 to 0.0625 up to 1. I can already tell that's not right. Let's check this one. On top, we've got the 0 to 1, 1 to 2, 2 to 3. That looks good. And on the bottom, we have 2, 2.1, 2.2, 2.3. This looks like the winner because here we have a change of plus 0.1, plus 0.1, plus 0.1. So this one is a linear function, constant rate of change. All right, number 6 says, an office supply company delivers boxes of paper to customers. Each box of paper costs the same amount, and there is a flat delivery fee for each order. Flat delivery fee, what that means is, doesn't matter how much paper you're buying, you're going to pay for this delivery fee. It also says the equation, let me highlight this, y equals 52x plus 35 represents the total cost for one delivery of X boxes. So X is boxes of paper. We want to keep that in mind as we look ahead. So it says which value does 52, and there's going to be a few of these types of questions. Which value does 52 represent in the equation? So I want to look at this and kind of think through what each thing represents. So it says the equation represents the total cost. So that means that y is the total cost. Y is the total. And my cost is made up by this flat fee. Plus, if I'm buying paper, I'm going to have to pay for the paper itself. And the amount I pay depends on how many boxes of paper, like I have over here. So if I'm looking at this, there's a number that it doesn't depend on anything else, and that's this number 35. So 35 must be my flat delivery fee. It's not being multiplied by anything. I'm paying that money no matter what. But I'm also paying, that's why there's addition, I'm paying this $52 times X. So if X is boxes of paper, this 52 here must be the money per box of paper, because I'm multiplying that times however many boxes I get. So which value does 52 represent? Well, that's the money per box. So let's look here. It says the slope of the equation, which 52, if we look at it as y equals mx plus b, that is m, so it is the slope. The slope of the equation and the cost per box of paper. Yes, that's what we decided. But I want to quick check through the other ones. The slope of the equation, that's right, and the flat delivery fee. No, the flat delivery fee was $35, so that can't be right. The y-intercept of the equation and the cost per box of paper. No, actually, if we were looking at as y equals mx plus b, this 35 would be the y-intercept, so no. And once again, this cannot be right because it's not the y-intercept. The best answer here is A. And sorry, these got a little bit off, but I think they should be right on your paper. Okay, number 7. The function represents the total cost. We've got another situation here. Total cost of purchasing one couch with, and X throw pillows. Throw pillows are those decorative little pillows you put on a couch. From a certain furniture store, and it's giving us the equation y equals $429.99 plus $25.99 times x. So it's asking which statement is true. So before I even start, I'm going to deconstruct this just like I did above. So we're buying one couch, so we're going to pay one amount for that couch, but then I'm buying multiple throw pillows. X represents the number of throw pillows I'm buying. It's not told here how much the couch or the throw pillows are, but I need to figure that out from this equation. So the function represents total cost. Once again, y must be my total cost. And then I'm buying one couch, which is probably a large priced item, so this $429.99 must be the cost of the couch. Which means that if X is the number of throw pillows, this $25.99 must be the cost, the money for the pillows. So let's look at our options here. The value $25.99 is the slope of the function, which that is true because it's $25.99x. If you think of it as mx, that is the slope. And it represents the cost of one couch. No, that's not the cost of the couch. The value $25.99 is the slope of the function, yes, and represents the cost of each pillow, yes. If we look down here, I want to keep reading. The value $429.99 is the y-intercept, which is true because it's b if you think of it as mx plus b. It is the intercept and represents the cost of each pillow, no. The value $429 is the y-intercept, that's true, and represents the cost of x couches. No, we're only getting one couch, so that is incorrect. The best answer here is definitely A. Okay. Next page. All right, it says consider the graph. Gives us a nice little graph here. And then it's asking which statement is true. So, need to be able to read this graph. So I'm going to first look at the labels on it. It looks like I have number of markers and then total cost. So it looks like as the number of markers I buy increases, my cost is also increasing, which makes sense. I also want to notice that the scale is not counting by 1. This scale is counting by 2s, and this scale is increasing by 50 cents. So I want to keep that in mind. So it says which statement is true? The average rate of change, which means the slope of the graph, is 0.25. So is the slope 0.25? Well, slope is rise over run. So let's see what my rise over run is here. So it looks like if I go up $1, because that's 1, this is only half. If I go up a whole dollar, how much over am I going? I'm going over 4. So be careful with scale here. But it looks like if I go up 1, I'm going over 2. So that would be 1 over 2. Oh, sorry. That is wrong. Not 1 over 2. 1 over 4. Sorry, I'm going over 4. Going over 2 grid spaces, but the value of that is 4. So this is 1/4. If you plug that into your calculator, it is the same thing as 0.25. So the average rate of change of the graph is 0.25. That's correct. And it says, meaning each marker costs 25 cents. Well, let's think about that. I've got cost per marker. So this is dollars. It costs $1 for every 4 markers. So if I divide this out, yes, this will be my dollars per marker. So yes, this is actually true. Then it says the average rate of change of the graph is 0.25. That's true, meaning 25 markers cost $1. No. The average rate of change of the graph is 0.5. No, we already found that it's 0.25. So A is the best answer. So just be careful with the scale there, and then you just need to think about what your answer means. All right, so I'm going to take a break here, and I'll pick up with the next section in the next video.